Hello everyone. Here we are going to explain about the experiment of analysis of FET and MOSFET with fixed bias, self bias and voltage divider bias using stimulation software. And the main objective of this experiment is to verify the analysis of FET and MOSFET with fixed bias, self bias and voltage divider bias using stimulation software. And I'm Charumadi and my teammates are M. Sumati, S. Nandini and MP Sonia. Before seeing the stimulation, we will see the little concept about this experiment. First we are going to see about the JFET. JFET is nothing but the junction gate field effect transistor is one of the simplest type of field effect transistor. JFET are three-terminal semiconductor devices that can be used as electrically controlled switches or resistors or to build amplifiers. And next we will see about the working of JFET. When a voltage VDS is applied between drain and source terminals and the voltage on the gate is 0, the two PN junction at the side of the bar establish depletion layers. The electrons will flow from source to drain through a channel between the depletion layers. The size of the depletion layers determines the width of the channel and hence current conducting through the bar. And next we'll see about it's a diagram of the JFET. JFET is nothing, it's a three-terminal semiconductor device with the gate, drain and source. Current conducting is by one type of carrier, electrons or hole. And next is the advantages of JFET. There are some advantages. They are the JFET has a negative temperature coefficient of resistance. This avoids the risk of terminal runaway. The JFET has a high power gain. This actually eliminates the necessity of using diverse stages. JFET has a smaller size, longer life and high efficiency. And next we will see the circuit diagram of the JFET self bias is R2 1 milliohm and VCC R1 we are giving 5 kilo ohm and we stimulate see operating point IR1 and V2 we are adding and now run this. We will get V2 9.06793 and I of R1 3.18641. And next we'll see about the JFET voltage divider bias circuit diagram. And we are giving VCC 25 volt and R1 or the 4 resistance R1, R2, R3, R4, R3 2.5 kilo ohm, R2 1 milliohm, and we are adding I of R1, V of 1 minus V of 3, adding the expression, and now we run this and we get V of 1 minus V of 3 13.89645 and I of R1 2.22071. And next we'll see about the MOSFET. And MOSFET is nothing but the metal oxide semiconductor field effect transistor. It's a semiconductor device that is widely used for switching purpose for the amplification of electronic signals and electronic devices. The MOSFET is either a core or integrated circuit where it is designed and fabricated in the single chip because the device is available in very small sizes. And the advantages of MOSFETs are, here's some below. It generates enhanced efficiency even when functioning at the minimum voltage levels. There is no presence of gate current. This creates more input impedance, which further provides increased further switching speed for device. This device can function at minimum power level and use minimal current. And is the application of MOSFET. Amplifier made of MOSFETs are extremely employed in extensive frequency application. The regulation of the DC motors are provided by these devices, as because these have the enhanced switching speeds, it acts as perfect for construction of chopper amplifiers, function as a passive components for various electronic elements. And it's a circuit diagram of the MOSFET voltage divider bias. We are using the 4 resistance R1, R2, R3, R4. And we are grounded. And we stimulate. Yeah, we are having the I of R1, V1 of minus V of 2. And now we run this, we'll get V of 1 minus V of 2, 8.46402, and I of R1 759.99739.